Democritus was one of the creators of the first basis for the atomic theory, which stated that all objects are made up of little indestructible and indivisible things called atoms. His model of the atom was just a round solid ball, though his discoveries were questioned because of no chemical explanation. He only knew about atoms and was missing the nucleus, electrons, neutrons, and protons. Aristotle disagreed with Democritus and believed that all matter on Earth were not made of atoms but of the four elements earth, fire, water, and air. He thought that instead of atoms, everything was made out of a small amount of these elements. Also, that all things are made of form and matter, which can only be changed with growth, decay, or motion. Antoine Lavoisier made the law of conservation of matter, which states that matter is conserved in a chemical reaction, and that atoms are neither created nor destroyed in a chemical reaction. He also distinguished between an element and a compound. John Dalton created the atomic theory of matter, which was built off of Democritus's plus his own findings. The theory stated that all matter is made of atoms, atoms cannot be created nor destroyed, and atoms of different elements combine in whole ratios to make chemical compounds. His research proves Aristotle incorrect. His research also supports Antoine's idea of chemical compounds. J.J. Thomson discovered negatively charged electrons. It also came up with a theory that atoms are uniform spheres of positively charged matter in which electrons are embedded. He created this model, popularly known as the plum pudding model. His theory was believed to be correct for many years, making Democritus's theory about the round solid ball model incorrect. Robert Millikan found out the measurement of the electric charge of a single electron. He also found out the magnitude of the charge itself using his oil drop experiment. Louis de Broglie created the theory of electron waves, which was a wave confined within the boundaries imposed by the nuclear charge would be restricted in shape and thus in motion, because any wave shape that did not, if within the atomic boundaries, would interfere with itself and be cancelled out. But his theory had no evidence. James Chadwick discovered the neutrally charged neutron, which gave another part to the atom model. With the help of Democritus's atom idea and his round solid ball model, Antoine's law of conservation of mass, John Dalton's theory of atomic matter, J.J. Thomson's old model of the atom, Robert Millikan's electric charge of a single electron, Louis de Broglie's theory of electron waves, James Chadwick's discovery of the neutron, Ernest Rutherford was able to come up with the atomic model. This model describes the atom as a tiny, dense, positively charged core called a nucleus, which all the mass is directed around, with which light, negative constituents called electrons circulate at some distance. Indefinitely, Aristotle's ideas had no contribution to this atomic model. In fact, Democritus's ideas about atoms and his first model of the round solid ball sparked many scientists to get their information on the atom. If it wasn't for James Chadwick in 1932, who discovered the neutron, and J.J. Thomson in 1903 to 1907, who discovered the negatively charged electron, plus creating his model of the plum pudding atomic model, then Ernest Rutherford wouldn't be able to create his atomic model, which is the complete version of a built-off of J.J. Thomson's model. That was just missing a few things like the protons, nucleus, and how the electrons were circulating around the nucleus.